All right, let's do number 59. Kathy Cool buys a sports car that can accelerate at a rate of 4 meters per second square. So let's draw the car. So this is going to be Kathy's car. All right, so there you go. So this is going to be Kathy. And she's going to accelerate at some, I'm going to call it 1A, at 4.90 meters per second square. And she decides to test the car by racing with another Stan, Speedy. Oh my God, the names. Both start from rest. But experienced Stan leaves the starting line 1 second before Kathy. Okay, well, it's a little, the wording is all screwed up here, but this should be before this sentence there. But okay, so Kathy has acceleration of this rate, and Stan has the acceleration of that rate. So let's write that down. So this is Kathy, and this is Stan. So this is the Stan vehicle. And Stan accelerates at the value of 3.50 meters per second square. So Kathy supersedes Stan's our vehicle. And Stan moves. Okay, so let's see what it says. So Stan leaves the starting line 1 second before Kathy. So Stan goes first, and that makes sense because it's a lower acceleration. And then Kathy is going to eventually overtake Stan. That's basically what this whole problem is. Stan leaves her before Kathy. Stan moves at constant acceleration. And Kathy maintains acceleration of 4.98. Find the time in which Kathy overtakes Stan. All right. So let's draw this, folks. Let's draw the x-axis, or the t-axis, I mean, and the x-axis. Okay. So this is the x-axis. So Kathy's going to leave at Stan is going to go first. So it's going to accelerate. And then 1 second later, I'm going to call T naught. T naught being 1 second later. So Stan is going to go first. So this is the motion for Stan. Stan is really just going to be 2y equals, and do they start from rest, right? I think they do. So we're just going to let the initial position be 0, the initial velocity be 0, and we're going to let the and it's going to travel at the rate of 2a over 2t square. So the question is asking for the time interval in which Kathy overtakes Stan. So Kathy equation is going to be 1a, the acceleration of Kathy, a time after t naught square. So those are your two equations there. Once you got your two equations, we're going to let the velocity for Kathy equals the velocity. The position for the Kathy is going to be the position for Stan. So this parabola, we're going to find the time. Doesn't really look like that, but we're going to find the time it takes for call it T1 for y2 to be y1. So the 1 of the acceleration for Kathy over 2 of, I'm going to call that T1 minus T naught, has to be equal 2 of the acceleration over 2 over T1. So that T1 is the time it takes for them for the position to match, for Kathy to match up with Stan. And so all you have to do is solve for T1. Once you solve for T1, folks, and I guess it's a bit involved. In fact, let me simplify it for you guys. So this is what I got. So this is what I ended up getting. 1a over 2 minus 2a over 2. I'm going to try and be neat here for now on. T1 squared minus 1a t naught times T1 and plus 1a t naught square over 2. The reason why I'm writing it this way, folks, is because you do need to use a quadratic formula on that one. So that's a little more involved when it comes to solving it, unless there's an easier way, which I don't really know and I don't really care, to be honest. So there we go. But either way, I found the time, and it matches to what I confirmed this. So the time it takes for them to catch up is going to be 6.46 seconds. And the position, and I think I did set this up correctly, is they're both gonna catch up at 72 meters. But let me see, find the time it takes. Okay, so this is A, the distance it travels before she catches them. Okay, so the distance is gonna be 72 or 72.99 meters. That's the time, that's the position. So that's going to be, so T1 is going to be 6.46 seconds, and the speed of both cars at the instant they take him. Okay, so let me just solve this right now. Since I stored up the time interval that it takes for them to catch up and the time for the positions for them to be the same, I'm going to find their respective slopes or their speeds. I mean their velocity at that point. So it's gonna look like that. And that's pretty straightforward because they start from rest. So one of them, so Kathy has this is the acceleration for Stan. So all you have to do is take that 6.46 seconds, multiply by the acceleration, 3.5 meters per second square. Same thing, take to the acceleration of Kathy, 4.90 meters per second square, multiplied by 6.46 seconds. And here you have the final velocity at T1. It's going to be 22 point actually that's Kathy. Oh no, that is Stan. So that's actually this. So let me change this a little. The final velocity for Stan is going to be 22.60 meters per second. The final velocity for Kathy is going to be 31.64 meters per second. Alright folks, hope this helps. Anyways folks, I'm going to fix this up a little. The final velocity for Kathy is going to be 26.74 meters per second. And the reason for that is because it's not 6.646, it's actually 5.46. So I fixed the answer for, actually I was going to keep it at 6.46, but it makes sense that the time in which Kathy overtakes the stand after Kathy leaves is going to be that many seconds. That's what they want. And then here's the final velocity. So I'll promise I'll get better, guys. All right. Hope this helps.